Alright guys, welcome to this page of the notes, and what we're going to do here in these problems, which I really enjoy a lot, I hope you like them too, is we're going to use the properties of logarithms, but this time we're going to go the opposite direction, right? Remember, in the problems we just solved, the equation had a log base plus a log base, or a log base minus a log base, and we rewrote that addition and subtraction as either multiplication or division. Now what you're going to do is go the opposite direction, where I'm going to give you a logarithm and we're going to split it up into a log base plus another log base, or a log base minus another log base, depending on the problem that we're given. I told you when we looked at those properties, the exponential properties of logarithms, you need to be able to go both ways. And now we're going to get a little bit of practice going the opposite direction. Now, a quick thing about these problems. If you take a quick look at the example problem I've got behind me, you'll notice that what I'm asking you to do is approximate the value of log base 4 of 192. Yeah, I know. You could just plug that into your calculator, do the log base 4 of 192, and your calculator will give you an answer. It'll be a decimal, and you'll get your approximation. That's why these problems, if you're taking this class with me, are not going to be multiple choice questions. I'm actually going to give these to you as free response questions. Free response questions just simply meaning you're going to have to show your work, right? They're partial credit problems, and your work is what gets you credit, not necessarily your final answer. What that does is it forces you to show me how you use the property of logarithms to break this guy down using the information that you're given. So let me go ahead and jump right into these. I'll show you how they work, and just keep in mind, I know you could use a calculator. Fine, use a calculator to check your final answer and make sure you did it right. Great, I love problems where you can check your work. But just know if you're taking this class with me, this will be a free response question, and that it's your work that's worth the points, not necessarily your final answer. So here we go. Let's show you how these guys work. Here's what I tell you. I tell you that you're going to use the log base 4 of 3, which I give you the decimal approximation for. But that's not the only information you have. Let me quickly write down what you know. Here's what I know. I know that the log base 4 of 3 is approximately 0.7925. But keep in mind, we actually know something else. I had mentioned to you guys anytime that the base of the logarithm and what you're taking the argument, what you're taking the log of, whenever they're the same, it's always going to cancel each other out and you'll be left with a 1. So keep in mind that you also know this, even though I didn't tell you, you do know that log base 4 of 4 is 1. And that'll be really, really important, and you'll actually need that for every time we do one of these problems. All right, so that's what I know. Now, what am I going to do? Well, I need to start with what I've been given, log base 4 of 192. And here's what I know. I know that I need to use what I was given and this extra little bit to go ahead and break this guy down. Here's where I'll start. 192 must, it has to be, since I gave you the log base 4 of 3, that means 192 must be divisible by 3. And it is. If you go ahead and use your calculator, you'll find out that 192 is 3 times 64. Excuse me. So let's write that. Log base 4 of 3 times 64. Well, now we come to that product property of logarithms, which says if I have a product, I can split them up using addition. So I'll have the log base 4 of 3 plus the log base 4 of 64. And now hopefully I think you can kind of see where these are going. Right here, log base 4 of 3. Well, I know what that is. I gave it to you. It's 0.7925. So I know that this guy right here is 0.7925. But I've still got this little bit right over here, log base 4 of 64. Again, it probably won't take you that long to be like, oh, wait a second, that's right. 64 is 4 to the third power. 4 to the third power gets me 64. And now you're like, oh, look at that. I have an argument raised to a power, and this is the power property of logarithms. I can take that exponent and drop it out front as a coefficient. Log base 4 of 3 plus 3 times the log base 4 of 4. All right, guys, so here's the way these are going to work, right? These are free response questions because I don't want you to just use your calculator to get the answer. I need to see this work. I need to see you showing me you know how to use those exponential properties of logarithms to break this guy down and get yourself down to what you know, right? Log base 4 of 3, I know, it was given to you. Log base 4 of 4, I know, that's an easy one. You'll always know what that is. As long as the base and the argument are the same, it'll always be 1. And you just multiply it by 3. So let me come right up here. Here we go. Log base 4 of 3, well, that's 0.7925, which I'll then add to 3 times 1. So I get 0.7925 plus 3, which is going to be 3.792 5. Again, if you were to go ahead and use your calculator to check your answer, log base 4 of 192, it'll come out to be 3.7925. That's the way these problems are going to work. We're going to use those properties of logarithms to break them down using the information that you've been given and the exponential properties of logarithms to help us out. I'll do the next example problem in the next video, so head on over to the next page of the notes and I'll meet you guys there.